Hey, welcome back. I wanted to talk about cheap 5C collets. I showed this 5C collet chuck here years ago on the channel. I took it apart and since then I used it, and really has been great value for what it cost, and I always got the precision out of it that I required. With the import 5C collets, there are some things that you can do to improve their performance in general. And since I took my 6mm collet and I modified it a whole lot for a certain part, I ordered a replacement collet. Super inexpensive 5C collet. And that's how these arrive. So theoretically, you could just go and use this right out of the box, but it's a good idea with lower end work holding or general with lower end tooling to take a closer look at it. First of all, we have a keyway in it. This aligns with a pin in the collet chuck, and this is razor sharp. It's terrible to handle, and also when you insert it, you have a sharp edge here, and this is prone to scratch the inside of the collet chuck. Also, this thread is kind of rough, so we're going to do something about that. Also, this is a 6mm collet, and this is a 6mm pin. Do you hear this? In a normal, good quality, nominal sized chuck, the pin should not stick, it should fall out. All the cheap import collets in this style are sprung close without a part in them. That means when you put a part in them, you bend the three leaves of the collet apart with your part, and you scratch along the surface of your part. And while that might not sound very bad, but if you work with parts out of aluminium and other soft materials like brass, bronze, nickel, silver, you will scratch the part that way. And there are a few things that we can do to improve the performance. Also, they are super sharp out here. One might say, yeah, just buy a Schaublein or hard-inch collet and don't bother. And I say, yeah, that's perfectly fine. That's very good to do. I think a Schaublein 5C collet costs about 4 times what this costs. So if we put a few minutes of work with a die grinder into each of these collets, well, that's some money saving here. Yeah, I know. There will be comments. I'm not even bothering to delete them. Just don't be mean in the comments, okay? Roman Ranchetti showed a trick where he takes O-ring stock and puts them in the slits of the collets and just cuts them off flush. And I do that to collets when I use them the first time, and that works excellently. The rubber in the slot of the collet acts like a spring and presses the leaves of the collet outwards. And that way you can put a workpiece or a pin, or in this case the pin, in the chuck without this scratching noise. Also, yes, emergency collets exist. Emergency collets look like this. They have these holes pre-drilled to insert short dowel pins, so you can clamp them rigidly and machine them, and then you can hold parts like in a soft jaw for a street jaw chuck. These are fairly expensive. Even the import ones are like, I think, around 20 euros a piece. Hard collet, 12, 14 euros, I think. And you can get them already with any diameter that you need as a starting position. So in the past I took hard collets and modified them for certain parts. This one this used to be a 3mm collet, but I bored it out to 3.8. And I put a 10mm counter bore in it, and I did this only for one certain part, and then it went in my drawer with collets. And if something else comes up, I can still modify it, or if the part ever returns, which it will not in this case, I can reuse it. But I have options this way, that way. Same for the 6mm collet here. It's kind of a consumable at this point. They are so inexpensive that you can just cut them down to whatever you need. So let's take a die grinder and do some work to this collet and then call it a day. Also, I have a little thing about 3-jaw chucks also to show. Let's do the outside first. These slots, I have a die grinder with a small aluminum oxide spherical mounted stone in here. And I just run it along those slits to break the edges. Okay, already a ton nicer to handle. Now we have this large slot here. We want something else for this. We can use a carbide burr or a stone for this. Let's use a straight carbide burr for this. Okay, that's the keyway. Already even better than before. The thread, we use a Cratex wheel, or you can use a heavy wire wheel on a bench grinder or in the drill press. But I like a Cratex wheel. I forgot to mention that what we're doing to the collet here does not change or improve the runout of it. Before you put some work into it, it's a good idea to put it in the collet chuck and clamp a pin and check the overall runout of the collet and see if it's worth putting the work into it or if you want to return it to the seller. The only improvement in runout is very minute, just by removing some burrs that might influence the runout, but the overall runout performance of the collet is not changed. When I do the thread with the Cratex wheel, I always go in the orientation of the individual threads this way, and the thread will form its shape into the Cratex wheel, and then you can just ride the thread with the wheel. This takes off any major high spots or burrs, or gives just a nice uniform feel. And we're already about 1000% better than before. Sometimes I do wire wheel the thread, sometimes I do a Cratex. There is no, it's not a set in stone thing. I just want, when I put this in the collet chuck and I have the thread that pulls it in engage, I don't want this crunchy feel of non-deburred heat-treated thread in there. One last thing that I want to do, or well, there are a few more things. When they make these collets, they always put a very heavy chamfer on the end, and I don't like that very much. Also, the face of the collet is crowned, it has a radius all the way up to the bore. I don't like that because often I rest parts with a face, parts of a shoulder, up against the face of the collet, and with a flat face I get a way more rigid clamping situation. So we're going to put this in the lathe and face off the front. Then we'll do the final deburr and also add the O-ring stock. Again, some of my collets have this done to them. This one, 7mm collet, has the end faced off. So when I put something with a shoulder in it, it can rest against the face of the collet chuck. I cleaned the collet in the ultrasonic cleaner just to get all the abrasive dust from the Cratex wheel off. And now we want to face off the end, so I'm going to put a 6mm pin in there, put it a little bit behind the end of the collet, just so that I don't have to face the hardened pin, and I clamp it. We find a suitable tool. In this case I have a CBN insert. that I'm going to use. Usually these collets are not really hard, so you can face them with a regular carbide tool, like carbide inserted tooling, or with a brazed carbide. And just to remind you, I just want a 2 or 3 millimeter wide band around the collet bore. There we go, that's all I want. Carbide chamfer tool to put the tiniest chamfer on the bore of the collet. Just big enough to clear the radius that's left from an irregular turning insert. There we go. Let's get it out, put the O-ring stock in, and do the final deburr and polish. Time to put the O-ring stock in. This is not for the faint of heart. You take a screwdriver, obviously your best one, and you mildly expand it. Then you take your O-ring stock. I don't have 3mm O-ring stock at hand, but I have an O-ring with 3mm cord diameter here. And you take a chunk of it and you insert it about maybe 8mm, 10mm wide, like this. Push it in. Try to do all three kind of symmetrical, just for looks. And the third one. Don't damage the bore when you hammer the screwdriver in, or damage yourself. That would be bad. Just like this. Screwdriver comes out, boink. There we go. Sharp blade, and slice it off, flush with the collet. Now take a 6mm pin. Whoop! Hey, doesn't stick, doesn't scratch. It has a nice wiggle room to go in without scratching the sidewalls or something like that. We moved some material around with the wedge. Would be maybe a good idea to do the wedge and O-ring before we do all the deburring, but eh. This is super fine Scotch-Brite. I'm just giving it a scrub to remove any remaining microburrs on there. I can hear the yelling at the monitor, but you're not altering any geometry with this stuff if you if you don't do this like a year long. Okay, let's put it in the machine. Well, before we do that, ultrasonic clean, because now it's abrasive all over. And what does this modified collet give you now? Well, we have a collet that is sprung open, and you can very easily put a part in it or get it out without scratching on the walls, due to the rubber springs we put in there. And we can clamp very nicely. Tighten down on it. And what do we get runout wise? I think that's not too shabby of a runout. That's about half a division on a 10 micron indicator. And with all my chucks I can bump them through if I need to. If you want to yell at me for buying a cheap collet chuck, please do it quiet, somewhere where I don't hear it, because honestly I don't care. I'm just slicing off the rubber that has been compressed out on first use of the collet. So thanks to Robin for sharing the O-ring stock in the collet slot technique. And yeah, let's go to the milling machine and look at the 3-jaw chuck over there. On the topic of work holding that's not meant to be modified, if you have a very inexpensive chuck like this one, this is a 100mm 3-jaw chuck that cost less than 100 euros, the jaw sets are also very inexpensive. A set of inside stepped hard jaws for this chuck is like, I think 25 euros including tax. And this relatively low price, well, that's still good money, but for what you get, it's fairly inexpensive. You can consider using them just like a soft jaw. Mill and cut steps and contours into it as the part you're working on desires or needs. In this case, I have a very small step milled in here. Just put a piece in here, a round material, and then I use a carbide end mill, in this case a 6-flute 6mm finishing end mill, and I cut a step in here. And the step is there, so this part can sit in there and has nothing under the part, so I can drill through. I will show that in a second. Important when you use hard jaws for something like this, they are case hardened, but not very deep. They're like maybe 0.5mm deep case hardened. And once you cut through the case hardening, you're basically in soft steel, softish steel. I put one under the hardness tester and it came out at about 30 Rockwell C, which is it's a soft steel. A completely unhardened mild steel doesn't read on the hardness tester. This reads at 30. A regular 123 block can be anything between 55 and 65. Keep that in mind. Once you cut through the case hardening, it's not a real hard jaw anymore. And it's just steel jaw. Also, just like with an aluminum soft jaw, very thoroughly deburr and round all the edges, otherwise you will scratch your work. The good thing is, on the steel jaws, it's way harder to embed accidentally chips into them. So they're very easy to clean, wipe off with a rag, compressed air. Or a piece of putty over the area of the jaws that you're using. The putty will pick up any fine chips and debris. And you can put your part in, hold it down, tighten it to the torque that you figured out beforehand, and you're good to go. Then you bring in your indicator, and you check your runout on the part. Do a little bit of correction because the machine was sitting overnight and there is thermal growth and shrinkage on these machines. Okay, there we go. That's good enough for this purpose. And here you can see why I did the step in the hard jaw to accept this part this way. When I come in with my 2.5mm drill, I will clear the jaw and not drill into it. So it's a good idea, well, it's an idea to consider the hard jaws on these inexpensive chucks as a consumable. And you can cut a lot of small steps and contours in such a jaw before it becomes unusable. And even when it's unusable, you can still face it off, put some threads into it, and bolt a block onto it and reuse it. Or you weld something to it. There is a shop nearby that does a lot of welded jaws. Also, on a 3-jaw chuck, what I'm doing here is a little bit dangerous. If you drill between the jaws, you're drilling above thin air, and you create a pivot through the 2 jaws here. There is a pivot line basically, and all that's holding the part from getting pushed down by the drill across this hinge line basically is the friction of the 3rd jaw pressing against the part. So it's totally possible to use a too big of a drill or too high of a feed and flip the part up if you drill out here in thin air. You either put a tiny screw jack under it or an adjustable parallel or something like that, or you use large pie jaws that support the entire part. Or you just don't drill above thin air. But in this case, I'm very aware what can happen, and also I'm using a fairly small drill and I'm running a fairly small feed by hand. So I have done 10 parts this way now, and I'm very confident that the setup is good enough for this purpose. I'm cutting one of the most annoying features for a manual machinist here, a precision counterbore. I set the boring head on a test part to the diameter that I need, so I don't have to adjust it each time on each part. I just change the boring head into the spindle and go for it. I'm taking a roughing pass down by hand feeding the table up to my depth of the bore. Then I engage the power feed and I do a spring pass out of the bore. I'm not power feeding into the bore because it's hard to hit a certain depth that way. And then I'm using a 3.01mm pin and a 3.02mm pin to check. The 3.01 goes in very nicely and the 3.02 does not fit at all. So the bore is between 301 and 302. Feels relatively loose with the 3.01, but that's always the case with small bores, small shallow bores. Those always feel very loose on a 5 to 10 micron range. So that's some shallow hole boring. Quick look in the chuck drawer. 6-jaw chuck, magnetic chuck. That's the soft jaw chuck that I modified from an old 3-jaw Emco chuck, where I cut down the jaws to give me the options to bolt on soft jaws, to do things like this, to hold, for example, these ring-shaped parts in here very securely without deforming them. And you might notice that these are pie jaws, which are a round disc and then cut in 3 parts, but the jaws are flipped around. Because I'm a cheapskate, I'm using them double-sided. Also, here are 4 sets of the hard jaws for the 3-jaw chuck that I showed earlier on the milling machine. I stocked up on them because I expect a fair bit of work that requires me to cut custom jaws in the near future. So, and that's all the chucks apart from the Collet chuck that's currently mounted on the lathe that I own. I don't own a 4-jaw independent, for example. I don't own a faceplate. Usually all of the work I do can go either in the 6-jaw or in the soft jaws. And if those two are not an option, I usually have the magnetic chuck if it's steel, or I can work around it. Sometimes a faceplate would be nice on some occasions, but I can usually, at this point in time, I can just hold a fixture plate, a sacrificial aluminum fixture plate in the 6-jaw to do that kind of work. So that's my chuck collection here. Oh, also, ignore the high quality labels. I reorganized a good chunk of the drawers over here and resorted stuff. And before I used the Brother P-Touch label printer to make proper labels. I used just masking tape and write down what's in there and wait for some time to figure out if the new system works out. For example, in here I have, speaking of cheap tooling, this is not cheap at all. This is a Arova ITS chuck. It's a zero-point clamping system that will go on the CNC router and on the Deckel FP1 milling machine. And you have these pallets that go in the chuck, and then you can lock it in place. And this, you can, for example, machine work holding features in here, or you can put something like a vise on here. These are brass ones. They are also available in steel, and you can get Collet chucks and stuff like that. These are usually used on rather high precision machines. But I got this from Becker Erodiertechnik. This is Arova compatible. The ITS system is a very standardized system by now. And this can go, the chuck will go on my CNC router, and I will probably mount it upright. So I can put parts in here, machine one side, then you can index it by 90 degrees and do the other side. That's just on a side note what might show up in the future here on my shop. Also, I have just indexing discs in here, or all the central clamping vices in here. So that's the reason for the blue tape labels on here. At some point, I will do proper printed labels, of course. Woohoo! So one might say that I should just buy the darn Collet from Schablin or Harding or whoever, and that's kind of true, because that way I would get a super high quality Collet that doesn't require anything to be done to it. The point is, if you order from somebody like that, you usually have to send a letter or write an email or send a carrier pigeon to get a quote. Then you order it, then they ship it, then you get an invoice, and it's a whole operation that takes forever. And by the time you have to call it, you already have forgotten why you ordered it. So many of the model and home engineering suppliers have web shops where you can just go online, click your line items, and order and have them shipped without ever having to talk to a person. The industrial suppliers and industrial manufacturers often still require you to go through a salesperson that doesn't add any value to ordering a standard item like a Collet or an end mill. It just makes stuff complicated, slower, and very inconvenient. There are places that are extremely good with having online shops like Hoffman Group, Misumi, or probably McMaster-Core. I never have ordered from them because they don't operate here in Europe, but I have looked at their website and their web shop looks very functional. Those get it right, but they don't have everything, so you still have to go through industrial suppliers and industrial manufacturers to directly order stuff, and that's usually bloody annoying. So that's one point. And the other point is, I know where my roots lie. I'm coming from model engineering and home shop machinist background. Well, I'm still a home shop machinist because I'm living here. But I'm coming from a model engineering background, and many model engineers have to be extremely budget aware since their shop doesn't make any money. And why shouldn't these people have the option to purchase and use collets and have nice collets with the option just to put a little bit of work into the collets and or every item that they purchased and make them way nicer than they started out with? So that's also a point where I'm thinking about it. Purchasing a €150 collet or a €1,500 three-jaw chuck from Schunk is often not an option for a small shop, for home shop machinists, model engineers. And they are stuck with the import tooling. And I want often to show options that you can use the affordable tooling to get very good results. So that's that. Also, if you want to yell at me for buying and using cheap tooling, please yell somewhere where I don't hear it, because I don't care. This is my shop, this is how I operate, and it is what it is. All the others, I hope you enjoyed. Maybe you learned something, maybe it was useful. Thank you all for watching, thanks for the support, and I'll be back. Woohoo!